Hi everyone, welcome to this lesson where we will learn about how to set up DNS on AWS using Amazon Route 53. I am Aishwarya Sood. I am a software engineer and AWS trainer by profession. I am AWS Certified Cloud Practitioner, AWS Certified Solutions Architect Associate, AWS Certified Developer Associate, and also an AWS Academy accredited educator. You can connect with me on LinkedIn. This is my profile name, and you can also scan this QR code to view my profile quickly. So in this video, I'll explain about Amazon Route 53, why it is required and what are the main functions of it. Then we will also look into the routing policies that are available with Amazon Route 53. And in the later part, we will discuss some benefits of Amazon Route 53 and also how to set up Amazon Route 53 using different routing policies. So let's start by looking into the process of DNS resolution. DNS stands for Domain Name System, and it's like the phone book of the internet. So humans access the information online through domain names like google.com or amazon.com, and web browsers interact through IP addresses, which stands for Internet Protocol addresses, and DNS translates domain name into IP addresses so that browsers can load the internet resources. Each device that is connected to the internet has a unique IP address which other machines use to find the device. DNS servers will eliminate the need for humans to memorize all the IP addresses, whether they are IPv4 addresses or even complex IPv6 addresses. The process of DNS resolution involves converting a hostname such as, let's say, www.example.com into a computer-friendly IP address such as a numerical IP address, which you can see on the screen, 10.20.30.55. An IP address is given to each device on the internet, and that address is necessary to find the appropriate internet device, like how the street address is used to find a particular home, right? And when a user enters a domain name into the browser, when a user wants to land a web page, a translation must occur between what a user types into their web browser, like the domain name, and the machine friendly address that is necessary to locate the example.com web page. So this is how the whole process happens. The user types the domain name into their browser, let's say it is www.example.com, and it goes to the DNS server. DNS server finds like what is the IP address that is related to this particular domain name. Once it is returned, it will be given to the web browser, and the web server will be able to find the content that is there with this IP address, and it will be returned to the user, and the user will be able to access the required information. Now look into the another need, like why we need Amazon Route 53. That was just one purpose. The first is DNS resolution, the another is this particular thing, and we will be looking into few more things, that why do we need Amazon Route 53 and what exactly it does to solve these problems. So suppose you are trying to open your web application and the URL that you hit isn't working. Lot of reasons can be there when the URL isn't working. There might be server utilization went high, or the memory usage is around 100%, or many more reasons are there. Like we often get some of these errors like 500 internal server errors, service temporarily overloaded, or 503 service unavailable errors. So the thing is that we do not get the proper information, like the errors cannot be resolved, they cannot be handled, because this is what we have configured. Okay, but what if we want a better solution? Then we need to have a proper DNS service, and here comes the Amazon Route 53 for that purposes. So Amazon Route 53 is a highly scalable and available DNS web service on AWS. It's a service that it is designed to give developers and businesses an extremely reliable and cost-effective way to route end users to the internet applications by doing the DNS resolution. And Route 53 effectively connects user requests to the infrastructure running in AWS, such as it can be EC2 instances, elastic load balancers, or Amazon S3 buckets, and can also be used to route the request to infrastructure that is outside of AWS. So it is not restricted to only the infrastructure on AWS, but also the requests can be routed to the infrastructure that is outside of AWS, like the on-premises infrastructure. So here are few functions that you can perform with the Route 53. These are like the main functions that we can perform with the Route 53. First is a domain registration. Route 53 lets you register a domain name for your website or for web application, and you can also use a third-party domain name with Route 53. That is also another option. Like you can register a domain name from the Route 53 itself, or you can get your own domain name and configure it on the Route 53. Then next is traffic flow. Route 53 it routes the internet traffic to the resources for your domain, and it helps connect the browser with your website or the web application. And then the third main function is the health checks. It checks the health of your resources and monitors the performance of your application. So this is what I was saying on the why Amazon Route 53 slide, that let's suppose if your server experiences a crash, what happens? A regular DNS would continue to redirect the users to the crash server, and they will be getting the errors because that's what you told it to do. But Route 53 can perform the health checks on your servers and redirect the users to a healthy resource while the problem is being fixed. So Route 53 sends an automated request over the internet to a resource such as a web server to verify that if it's reachable, available and functional. You can also choose to receive notifications when a resource becomes unavailable and choose to route the internet traffic away from the unhealthy instances. So that's the another great benefit of Amazon Route 53 if you want to handle the errors which comes on the crashed web server, so that the user request can still be served through a healthy server. So you might be thinking that what is exactly the meaning of the name Amazon Route 53, and it's also a very common interview question of AWS, that why Route 53? What's the meaning of this name? So AWS Route 53 takes its name with reference to the port 53, which handles the DNS for both the TCP and UDP traffic requests, and the term route signifies the routing. That's how it is named as Route 53. Now let's see how to configure Amazon Route 53 and how does it exactly route to the request. What are the all the options that are available, and what are the configurations that we have to make on Route 53 in order to properly do the DNS. So first thing that we will be discussing is the first part, that is here. The very first thing that you need to have is a domain name. Okay, like www.example.com, google.com, any domain name specifically you want it. You can either register it from the Route 53, or you can also register it from a third party, and you can configure it on Route 53, and you can do the further settings for the third party domain as well. Next is a hosted zone. So I'll show you in the console as well. First let me tell you what exactly it is. So a hosted zone is a container for the records I'll be telling you next, and the records contain information about how you want to route traffic for a specific domain, and such as example.com and its subdomain, it can be abce.example.com. and there are two types of hosted zones that are available. One is public hosted zone, another is private hosted zone. So let's look into look on the AWS console. How do we set this? So let's go to Route 53 to set up the DNS. Currently I do not have the domain name, so I'll not be doing the actual configurations. I'll just show you as a sample, but you can follow the same thing for the configurations later on. So just click on create hosted zone, and here you first thing will be this thing. Before creating a hosted zone, you need to have a domain name. So for now I do not have the domain name, so I'm just showing you how to set up from the hosted zone step. Here you will have to type the same name as the domain name. Let's say my domain name was mydemodomain.com. That can be let's say I had that domain, so I am writing that, but you have to write the original domain name that you have. For that only you have to create a hosted zone, and you can add a description. And now come to the point of types of hosted zones that I was telling on the slide. So you can configure it to be either a public hosted zone or a private hosted zone. Public hosted zone contains the records that that specify how you want to route the traffic on the internet, and a private hosted zone contains the records that will specify how you want to route the traffic in an Amazon VPC. So for now, let it be the public hosted zone. Anyway, we are not going to route the actual traffic, but we are just doing the sample thing. So you can add the tags as well. Other settings, description I am not adding, so I am leaving it as default. Create hosted zone, that's it. So once you have your domain name for bringing it, like if you have a third party domain name, what you will have to do, once the domain name, the hosted zone has been created, you will have to copy this name servers and add it to the domain that you have. You will have to replace its name servers by these name servers, so that it can be connected and the traffic can be routed properly. Next setting that we will have to do is records. So we will have to create records in a hosted zone. Domain name, if you have, okay, this step is done. Then we will create a hosted zone for this particular domain name. Okay, let's say in our example it was mydemodomain.com. Then after the hosted zone has been created and the name servers has been properly configured, then I will be creating records within my hosted zone. So what are exactly records? Like after you create a hosted zone for your domain, such as which was mydemodomain.com in our case, you create records. What is the purpose? They tell the DNS how you want the traffic to be routed to that particular domain. Each record includes the name of the domain or a subdomain, a record type, and other information that is applicable to that record type. Let's look on the console. How do we create the records? So this is the hosted zone has been created. They will come by default. If I want to create a record, I will just have to click on this create record, and here I can specify multiple things. First will be the record name. So it will be like whatever record name I specify, it will be ending with this suffix mydemodomain.com, whatever is the domain name that I have got. Then I have to tell the record type. So there are multiple record types. You can look into all of them. Like for now, I'll be keeping it as a record which routes the traffic to an IP address and some AWS resources. Okay, you can go for 4A record, that routes the traffic to IPv6 address and some AWS resources, and further records as well. You can check out all of them. For now, let's keep it as A itself. And here you will specify the value of the IP address. Let's say you have an EC2 instance. Okay, so you want to route the traffic to that particular EC2 instance. Maybe your application is hosted on that. So you will specify the value here, the IP address, the public IP address value here, and here you will set the TTL. So TTL I'll be telling you in the coming slides. Let's skip this as of now. Here I'll be choosing the routing policy. Okay, there are multiple routing policy, and this was the next step also, that we have to select the routing policy. So after you create a hosted zone for your domain, such as example.com, or which in my case is mydemodomain.com, you create records. That also is done. Now when you create a record, you choose a routing policy which determine how the Amazon Route 53 responds to the queries, and how the requests that are coming from the users, how they are routed to the backend servers. And there are multiple routing policies that are available. You can check out the complete list. So the types of routing policies, there are simple routing policy, failover routing policy, geolocation, geoproximity, latency based routing policy, and multi-value answer routing policy, and weighted routing policy. So I'll be telling you about all of them one by one, and we will see how we can configure it on the console. So let's start looking into policies one by one. First is the simple routing. So simple routing is like it lets you configure the standard DNS records with no special Route 53 routing. Okay, just the simple routing will be there. I'll show you how does it do that. And with simple routing, we typically route the traffic to a single resource. For example, when you want to map a single URL to a single server for the website. Okay, so let me take the pen and show you how it looks like. Let's say this is the server that on which my application has been hosted, and the IP address for this may be 54.23.23.10. Let's say this is the IPv4 IP address for my this EC2 instance web server, and these are the requests that are coming in. So Route 53 will just send all the requests that are coming in to this particular server. That's it. I am not specifying any kind of special configurations with this particular routing policy. I am just configuring the Route 53 with the simple routing policy, which will send all the requests that are coming to the single server itself. My application is hosted on a single server, and this simple routing policy is good for the single server environments. And to configure it on AWS console, let me show you how do you do that. So here you just need to create a record. Let me name it as simple because I am creating a simple routing policy. Simple.mydemodomain.com will be the URL for this one, which will be mapped to the particular IP address for my EC2 instance. Let's say my EC2 instance IP address is this one. This is not the actual IP address, but just to give you an example, let's say this is the public IP address of my EC2 instance. So this will be the record name or the URL by which you will be able to access this particular EC2 instance. Record type, I am keeping it as A, and TTL I'll be telling you in the next routing policy, because here we just have one server. And routing policy, I am selecting simple routing. I can select any of them and we will be looking into all of them one by one. For now, let's keep it as simple routing, and you just need to click on create records, and the simple routing policy, a record with the simple routing policy will be created in the list. So this is how I configure the simple routing policy for a record. Now let's look into the another next routing policy, that is failover routing policy. So this routing policy is used to configure active and passive servers. Let's say I have two servers on which my application has been hosted. This is the first server and this is the second server. Okay, this is the active one and the next is the passive one. So it lets you route the traffic to a passive resource when the active resource is unhealthy, and so it basically failovers to the resources. And this is mainly used when we have a primary site and a disaster recovery site. Let's say the requests are majorly coming to the active server. For the normal times when the active server is healthy, it is working fine, all the requests will be coming to the active server. But in case this server becomes unhealthy, okay, this is not responding well, and Route 53 marks it as unhealthy. What Route 53 will do? Route 53 earlier was routing all the requests to the active server, but now no request will be sent to the active server. Instead, it will be sent to the passive server. All the requests that are coming from the users, they will be routed to the passive server. So this is how the failover routing policy works. Let's see on the console how do we configure the failover routing policy. Again, we just have to click on create record. So it will open this page where we create the record. Here I will, let's say I give the name as failover. This can be anything. For this demo, I am just giving these kind of names like failover.mydemodomain.com. Okay, record type, I am keeping it as A. Here the value for the primary one will be there. So we will have to change the routing policy first. Let's say change is to failover routing policy. You can see more settings have come now. So the value for the primary server which I want to keep, if I select the failover record type as primary, here whatever value I type it, let's say this is my first EC2 instance IP address. So here will be the IP address for the primary record type, that is a primary EC2 instance where my application is hosted, and I am considering it as the active site, routing policies failover, and here I have to choose a health check. So first I will have to create a health check, okay, so that it can perform it on the servers. Then I will be able to find it from the list, and I just have to give a record ID, which is nothing but a unique name that will identify the particular record. Okay, and for this I will have to create one more record. So in the same page itself, click on add another record, and let's say this also has the same name, failover dot mydemodomain.com, and the record type is also same. Value now will be different because I am selecting failover. Here also I selected the failover, but the record type is primary. Here I have to select it as secondary. Okay, so here I will give the IP address. Let's say the secondary EC2 instance IP address is this one. So I am configuring it as a secondary IP address. Here the health check is optional. Okay, because if I am keeping two primary servers and one secondary server, in that case I can choose a health check here. Otherwise I can, if I am just keeping one primary server and one secondary server, then health check is like I can skip this point as of now. So here in this setting, one is a primary server, another is a secondary server. If the primary fails, like whatever health check I configure, if the primary instance fails, the requests will be routed to the secondary server for which the IP address has been given here. Now let me tell you about the TTL setting as well. So let me take the whiteboard for that. So the TTL, first of all, it stands for time to live. TTL stands for time to live. So the amount, it is the amount of time which will be specified in seconds that you want the DNS recursive resolvers to cache information about the specific record. Like if you specify a longer value, maybe of 2 days, you reduce the number of calls to that DNS recursive resolvers that the DNS resolvers must make to the Route 53 to get the latest information in the record. So what does that mean that I just said? Let's say I have 2 records. Okay, like we are currently talking about the failover routing policy. So let's say this is my first EC2 instance, this is my second EC2 instance, this is the active one, and this is the passive one, or the primary secondary you can say. So for this particular EC2 instance, in the console, if I specify the TTL is equals to, let's say 300 seconds. If I say the TTL is 300 seconds for the active server, and for the passive it can be a different one. Let's say for this one I am keeping it at 900 seconds. Okay, so what happens? The Route 53 will keep sending the request to the active servers for the time of 300 seconds. Okay, so whatever requests are coming to the Route 53, it will keep sending them to the active. That is like by default, yes, it will send to the active, but it will also check the TTL. Once it sends the request to the active, it will store them in the cache. Okay, so it will store them in the cache so that the DNS resolver do not make the request to Route 53 again and again to take the latest information. The request basically it will be cached for 300 seconds. Let's say after 200 seconds, my active instance fails. What happens in that case? Then also Route 53 will send the request to the active EC2 instance itself unless and until the TTL expires. So until the 300 second expires, till that time it will keep sending the request to the active server itself. Okay, after 300 seconds it will move to the passive one. So this is what is meant by the TTL. We will look into the TTL setting in other routing policies as well. This was about the failover routing policy. So this has a similar function in the other routing policies as well. Let's look into the another routing policy, the next one, which is geolocation routing policy. So this routing policy will be used when we want to choose the resources. Like it lets to choose the resources that serve the traffic based on the geographic location of the users. What does that mean? Let me take the pen here. So let's say I have a global application and for which I have kept two servers. One server contains a website that is hosted in English, that is translated in English, and the same website, it has been translated to Spanish. Okay, it has been hosted on the second EC2 server. So I can specify in the geolocation routing policy, if some request come from let's say England, or it comes from USA, the request should be routed to the server that contains a website that is translated to English. Okay, and if I say the request come from Spain, then it should be requested to it should be routed to the web server which contains a website that is translated to Spanish. So it helps in localize our content, that to present some or all of the website and all of our website in the language of the users. For example, like this one. Okay, some user from the US is reflected or redirected to an English website, and the another user from the Spain, he has been redirected to the Spanish website. Same way I can have multiple servers. Let's say this website is translated to French and is hosted on another EC2 instance. This was first one, this is second one, and this is third one. So that if some request comes from France, it will be routed to this particular EC2 instance which contains a website that is translated to French. So let's see in console how do we configure a geolocation routing policy. So again, click on create record, and I will have to give a name for my record. Let's say I'm giving it as geo.mydemodomain.com, and record type same A type, and value will be given here. But first let me change the routing policy. Now I am talking about geolocation. So here I can select the location. Okay, let's say I can specify it through the country or through the continent or through the country. If I say any request that is coming from Asia, it should be routed to this particular EC2 instance whose IP address is this one. Okay, or I can add one more record. Some name should be given here. Then I will select geolocation, and here I can specify if the request is coming from Africa, it should go to the particular EC2 instance whose IP address is this one. Okay, so in the first record, it is sending all the requests that is coming from Asia to this EC2 instance, and in the second record, I am specifying any request that is coming from Africa, it is being redirected to this EC2 instance which has the IP address 11.22.33.44. This is how I configure a geolocation routing policy. Now let me check the another routing policy. Next policy that we have is geo proximity routing policy. So it lets Amazon Route 53 route the traffic based on the geographic location of the resources. Okay, earlier we were talking about the geographic location of the users. Okay, here we are talking about the geographic location of the users and the resources. It also has an option to route more or less traffic to a given resource by specifying a value which is known as bias, and bias will shrink or expand the geographic region from which the traffic is routed. So I can specify that on one location the traffic should be like less or more it should be sent. And geo proximity routing policy, I can configure it through the traffic flow option on the console itself. Like it is not directly available from this page itself. Here I cannot select the geo proximity. You can select it from the traffic flow option. It is available on the Route 53 console. Next policy that we have is latency based routing policy. So just like the name says, if an application is hosted in multiple AWS regions, performance can be improved for the users by serving the request from the AWS region that provides the lowest latency. Like basically the nearest location, the request will be served to the through the nearest location that is present, so that the latency can be reduced and the users are able to see the content faster. So let me show you how do we configure this one on the console. This also has a similar process, like almost all the policies will have almost similar process, just few changes will be there. And for this also I will give a name. Let's say I can give it as latency.mydemodomain.com. Again the record type is same. The value I will give for my server, and here the routing policy I will have to select the latency routing policy. And for latency based routing I have to create records in multiple regions. So here I will select one region, let's say Africa, Cape Town. I will have to add another record and I will have to select another region. So if I select latency, this setting will be open. Here I will have to select a different region. I have to keep it in multiple regions. The latency records will be kept in multiple regions. So this is how I can configure the latency routing policy. Let's move to the next routing policy, that is multi-value answer routing. So it lets configure Amazon Route 53 to return multiple values such as IP addresses for the web servers in response to the DNS queries, and we can make 8 records. Okay, we can make up to 8 records, and Route 53 will respond to the queries from these 8 records. And what we get from this is we are distributing the traffic to multiple servers instead of just one server like we were doing in the simple one, and they all will respond to the queries in a random fashion. So let's say I can have up to 8 healthy records. Okay, there can be 3, there can be 4, 5, 6, 7, up to 8 can be there, and all of them should be healthy because it also checks the health of the resources and returns the multi values only for the healthy resources. Let's say I have 4 EC2 instances. If they all are healthy and some request comes in, it will route the request randomly, maybe first time to the first server, second time to the fourth server, third time to the second server, and fourth time to this one. Okay, it is just random one. It is not like fixed. It will return, it will send the request to any of the servers randomly. There can be up to 8 healthy records. Up to 8 can be there. Okay, so this is about multi-value answer routing, and let's see how do we configure it in the console. So here again, just give a record name, a record type, the TTL as like I explained earlier, and the value for the server that you want to route the request to, and select the multi-value answer routing. Here you can also select the health check, and you have to give the record ID, just a unique name for your record, and the value. So same way there can be up to 8 healthy records to which the requests will be routed randomly. Okay, and let's look into the last routing policy that is here. Next and last one is a weighted answer routing. So this one associates multiple resources with the single domain name or a subdomain and choose how much traffic is routed to each resource. What does that mean? Let me take an example here. Let's say I have I have 2 servers, and I am choosing the weighted routing policy. So what it will do, I can specify the weights for each server. This is a first server, this is a second server. I specify the 80% of the request should go to this server, and 20% of the request should go to this server. So what it will do, 80% of the times whatever the requests are coming in, 80% of the times they will go to this particular server. Only 20% of the times some request will be sent to this second server. Okay, based on the weight that I specify, the request will be routed to each server based on like whatever weight, whatever is heavier, more requests will be sent through that server. So this can be useful for a variety of purposes, like including the load balancing. When load balancer, the normal load balancer, you do not have the option for that, you can go for this one. And also for testing a new version of the software, like on the production server, you do not want to perform the test, obviously, right? You can perform the testing by routing the traffic to another testing server, like just 20% of the traffic, so that you can see if it works fine, you can shift all the traffic to the second server. And how do we configure that in the console? Again, the same thing, the record name, record type and value, and I have to select a multi-value answer routing policy. Here I have to select the, sorry, not the multi-value, the weighted routing policy, and here I have to specify the weight. Okay, so for this particular server, let's say 1.2.3.4 is my server's public IP address, and the health check is optional here. Record ID, again a unique name here, and weight I specify that 90. Okay, so I can add one more record. Same thing, settings I will do the same and select the weighted routing policy, and here I can specify the weight as 10. Okay, based on like this, I can distribute weight to multiple servers, and based on the weight that I am specifying, it will be routing the request to them based on what server is like heavy in the weight and what is lighter in the weight. Based on that, the requests will be routed. And here the TTL also I can give a example here. So let me clear this first. So what happens here also, let's say I have two servers. One server is having a heavy weight. Okay, let's say it is having 90 and it is having 10%. So here if I specify the TTL for the first server is equals to, let's say, 500 seconds, and here I specify the TTL is equals to 200 seconds. So what happens if some request is routed to the first server, which is like for which I have set the 90% weight. So 90% of the times it is like, let me not take the 90 and 10, let me take the 50-50 itself. So 50-50 I am taking. So what happens, it is more easier to understand, that's why I changed the weight. Let's say 50% of the weight to this one, 50% to the second server. So what happens, what ideally should happen, first time when I request, it should give me the result from the first server, and when I refresh the page, it should give me the result from the second server, because 50-50% is happening. But based on the TTL, what will happen, first time it will show me the result from the first server. Okay, the request is routed to the first server, and for the next 500 seconds the same result will be shown because it has been cached by the Route 53, and for the next 500 seconds I am going to see the result for the first server itself. Although the weight was 50-50, but the TTL is more in the first case, and for 500 seconds it will keep showing me the same thing. Once the TTL expires and then I refresh, then it will show me the result from the second server. So this was about weighted routing policy. Next are the few benefits of Amazon Route 53. So let's quickly finish this benefits, and that will be like almost the last topic of this lesson. So first benefit that is there is highly reliable. It is built using, like, Amazon Route 53 is built using AWS highly available and reliable infrastructure, and the distributed nature of our DNS servers helps ensure a consistent ability to route the end users to the application, and they ensure the reliability. Next is the flexibility. Then Amazon Route 53 traffic flow routes the traffic based on the multiple criteria such as endpoint health, geographic location, and latency. Like we have seen all the routing policies. Also with the self-service sign-up, Route 53 can start to answer the DNS queries within minutes. Next, that it is cost effective. So Route 53 passes on the benefits of AWS scale to you. Like more the customers are engaging into the AWS, they will be getting savings on their sides, and they will be passing on the savings to the customers by reducing the pricing of the services. So that's how AWS makes the services cost effective, and you pay only for the resources you use, all at a low cost and without minimum usage commitments or any upfront fees. Next is that it is scalable. So it is designed to automatically scale to handle very large query volumes without any intervention from you. You do not have to bother at all for the scalability of Route 53. And next is it is secure. By integrating Route 53 with AWS IAM, you can grant unique credentials and manage permissions for every user within your AWS account and specify who has access to which parts of the Route 53. and then it is compatible. That means it is designed to work well with other AWS features and all the offerings. You can use Route 53 to map the domain names to your EC2 instances, to the S3 buckets, to the CloudFront distributions, and also with the other AWS resources. So this was all about Amazon Route 53 basics and all the routing policies. I hope you have understood all of this. We will meet in the next video. Thank you.